Good morning and afternoon. It's a pleasure to welcome you to our broadcast titled Troubleshooting Redis, Performance Insights with Redis Labs Enterprise Cluster. Today you will learn problems that you can resolve with visibility into critical Redis metrics such as read and write operations, latency, as well as throughput at the database, node, and cluster levels. Our presenter today is Madhu Murthy. Madhu is a solutions engineer at Redis Labs and has over 18 years of experience in the database security space. Madhu has expert skills in application, data center, network, and workflow design, and received his MA in computers from NKU University. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. Madhu will be taking questions throughout the broadcast. There is a question and answer feature in the control panel that you can use to post questions. All questions will be answered in the order that they are received. Thank you again for joining us today, and at this time, I'll turn the broadcast over to Madhu. Madhu, take it away.
Thank you, Sharon. So to get started, a brief introduction about myself. I'm a senior solutions architect at Redis Labs with about 18 years of experience in the database world, being a DBA, with managing several RDBMSs out there, and then worked in the security space for quite a bit. I've been told that I do talk fast. Please try to keep up, but I'll try to slow down as much as I can. So to get started, this is the agenda. I'm going to talk a little briefly about the Redis Labs architecture. I think that's extremely important to understand before we start talking about the performance monitoring and the Syslog integration that we provide. Who are we? So Redis, as you all know, is an open source database that was started by Salvatore Sanfilippo back in 2007. It's one of the leading in-memory database platforms that's being deployed across all verticals for various types of applications. And Redis Labs is the home of Redis. We are the commercial provider for Redis. And who are we? We were founded in 2011, headquartered in Mountain View, California, and we sponsor the open source Redis project. We have two kinds of solutions that we offer. One is the Redis Cloud Services that's available across multiple cloud solutions, and the other one is the on-prem solution that's the Redis Labs Enterprise Architecture. Without further ado, let's dive into the architecture itself. On the left side, you actually see three gray boxes. These are nothing but nodes, and a node by definition, according to Redis Labs, is something that's running an operating system. The software itself is platform agnostic, so you could basically run this in the cloud environment. It could be AWS, it could be Azure. You can run it in your own data center on a bare metal server, or it could be an ESX environment. We normally suggest that you have an uneven number of nodes for primarily two reasons. One is to have the quorum. The second one is to handle any kind of split partitions or network partitions you may have. The Redis Labs software has been optimized to handle such kind of failures. The installation is about 10 MB, and it takes about a couple of minutes to install on each one of these nodes. And the entire cluster can be set up and running in 5 to 10 minutes with the database created and available for the application. When you install the Redis Labs Enterprise Cluster software, there are several components that get installed on each one of these nodes. And let's go over each of these components. One is the zero latency proxy. As the name suggests, it's a zero latency. It's been developed by Redis Labs. It's owned by Redis Labs, and it's fully supported by Redis Labs. The proxy has been developed in C, and it has several functions or several advantages. First of all, it is multi-threaded. And secondly, it acts as an interface between the clients connecting to the Redis cluster and the backend Redis database. So basically, being a multi-threaded, it can actually provide a better performance to all the clients connecting to the zero latency proxy. The third advantage is that the proxy maintains persistent socket connections where available to the backend shards. A shard, by definition, is an instance of Redis. It could be a logical unit of an entire database that constitutes multiple instances, or it could be a one-to-one mapping. So the proxy maintains these persistent connections to the backend shards, kind of like connection pooling. Again, the idea is to not make sure that there's no overhead on the Redis database itself, and it can function. The fourth advantage of the proxy itself is to force each of the shards as you scale your database, as you scale your Redis database, and you start creating more shards. It's going to force each of these shards and try to use a new code that may be available on the box. That's how we make it faster and basically a multi-threaded application. So the advantage there is multifold, right? One is your application is faster. Secondly, you're now taking advantage of all the resources that you may potentially have on that given node. The cluster manager is a sophisticated governing function that provides capabilities such as sharding, provisioning new databases, migrating these shards, failing over these shards, and also ensuring that there is optimal response should there be a failure. So basically, the set of processes that are running on each one of these nodes communicating with one another and has been optimized via the watchdog profiles that are actually monitoring the node and the cluster itself, optimized to handle failures. It could be a node failure, it could be a proxy failure, it could be a shard failure. And each of these different scenarios that may potentially happen, the cluster is able to recover by itself and continue to provide data to the applications. The third piece is a REST API. The REST API has two primary functions. One is the ability to provide the different metrics that we actually have in the user interface. So basically, we have metrics at the cluster level, we have metrics at the node level, we have metrics at the shard level, and we have metrics at the database level. So you have the ability to use a REST API, and some of these things that we're going to talk about during the webinar. Use a REST API, extract these metrics, and populate it in your event monitoring tool. It could be a SIM tool, it could be Splunk, it could be anything, and you have the ability to define escalation process around that. The second advantage of the REST API is if you're an API shop and you like automation, you can take advantage of the API itself to automate a lot of things. That includes changing parameters for a given database for the cluster itself. That includes defining replication. That includes scaling your database if you have to increase the number of shards, defining alerts, monitoring different aspects of the database itself, or create a multi-tenant environment. So the last piece is the Redis instances itself. So again, as I mentioned earlier, we are the home of Redis. The idea behind Redis Labs is not to move away from the community edition. The idea is to take the community edition and make it easily deployable, extremely flexible, and easily manageable in an enterprise environment. Any questions? Is the RLEC node, I have a question here, is the RLEC node the same as a server? Yes, the answer is yes. An RLEC node is the same as a server, but the difference is that you can have as many shards as you want, or as many shards as you want on that particular node for a given database, and as long as the resources permit on that particular node. Do you support ASP.NET projects on a Windows platform? Absolutely. Regardless of how the Redis Labs cluster has been deployed, basically we support the Unix systems. That's where the Redis Labs cluster is deployed. However, your .NET applications are using the Redis protocol to actually communicate with Redis. So it is completely irrelevant as to what operating system it's deployed on. Your existing applications will continue to be supported. Is there redundancy in the zero latency proxy server? Absolutely. So there are two kinds of redundancies today. We have an active passive mode wherein as soon as you turn on replication, you have an active node at the endpoint itself where it's accepting all the traffic. Should there be a failure on that node, the passive node is promoted as an active endpoint or an active proxy and continues to accept connections from the application. There's also another mode where we have the multi-proxy option where you can easily distribute the load across multiple nodes. So moving on, why do we want to measure performance, right? The popularity of Redis stems from its speed, its stability. Redis is faster than other schemaless NoSQL databases, and it's designed to act as a system of record rather than just as standard cache. So while we are doing this, since you're actually deploying this as an application for performance, it becomes imperative that you start to monitor the performance of Redis itself. And some of the factors that influence the performance of Redis are memory, cores, how many cores do you have on the box, the operations per second, how is the operations per second influenced by what you're doing. It could be by means of data structures, it could be by means of the hardware that you have deployed it on, and the connections, how are the connections working, right? How many connections do you have? Are you actually handling the resources properly? Are you closing out connections? Are you keeping the connections open for long? Are you tracking these connections? And there are a few other considerations. So we're going to go over each one of these here. So the first thing, when we start talking about memory, the critical aspect is how do you assess memory requirements? And very often when I'm talking to a lot of customers, what I do here is, okay, my data set size is 30 gig. All the different keys that I have add up to about 30 gig, and that's what I'm going to define across a 3-node cluster, for example. Maybe that's not the right approach. If you intend to have high availability, and one of the things I do recommend is high availability, having a slave so that, you know, in case of failure, you're able to recover, and for persistence reasons also, your total data set size, let's assume as an example, is 100 gigs, your total data set size would be 200 gigs. Because every slave will be an exact copy of a master. So if you have multiple masters within that 100 gig, you'll have the same amount of slaves. However, they all amounted to a total of 200 gigs. So as an example here, what I have is the used memory. As you can actually see, this is a very small database. But this is the total database size about 410 with 2 masters. And each has equal distribution. That's 200 gigs and then 2 slaves of 200 gigs. So it's critical when you're actually planning the data set size, it's critical that you plan for both the master and the slave. The second piece is the replication itself. Replication as defined in Redis Labs Enterprise Cluster is a process of replicating data from a master to a slave. In RLEC, Redis Labs Enterprise Cluster, there's no direct access to the slave from the application unless failed over or it's promoted to a master. The idea is to ensure the integrity of the data. So if you see the example here, I actually did a little bit of statistical information here. So if you see the example, I have a master that's been loaded with data, right? I have about 1.75 million operations per second with 11.13 latency. And the used storage is 52. The moment I turned on replication, or I defined the slave, I defined high availability, not only did my actual size go up, that's 100 gig, but there's an additional usage when you do this of maybe another 10 gigs. There's an overage. And the reason is I actually turned it on after I have loaded my data to 100 gigs. So you have 2 choices. You either plan for that, and it's always best to plan for that, or you start to define a slave right at the beginning of your database definition and you're loading the data. The second option, the second thing that you need to keep in mind is a replica of. A replica of is a feature that is provided by Redis Labs. So it's basically the idea is to replicate the data from an existing database to a different database within the same cluster. We provide a multi-tenant environment for Redis within the same cluster, or you could replicate that data from an existing cluster to a different cluster. And this could be for different reasons. This could be for DR. This could be to balance traffic out. This could be for geolocations. Or this could be as simple as having the data to test, having the production data to test. However, what you do need to keep in mind is when you turn on the replication, there's always an overage. Because now you're trying to transmit an entire 100 gig or 200 gig data over your network pipe, right? At least for the first thing. So once you actually have that definition, if you identify that there's a need for a replica of option, you will have to consider an overage of at least 30% of the memory in addition to what you already have for the databases. So the next piece that you have to consider from a memory standpoint is the persistence itself. As you all know, there are 2 kinds of persistence strategies with Redis. That's the append-only file, and the other one is snapshot. So typically, the potential impact from a memory standpoint for an AOF is minimal, except for the first time. So when I say that, what I mean by that is if you just loaded all your data of 100 gigs and then turn on AOF, there will be an initial impact. There will be an initial consumption of memory since it's actually persisting to disk. And then it'll go back to normalcy. On the other hand, a snapshot will have a greater impact on memory. And there's a possibility that you may double your memory depending on how many writes per second you're performing within your database, right? So there's an extreme case where you could end up having to use double the memory of your database if you're snapshotting at regular intervals. So depending on, this is something, again, you need to factor in. If I'm doing an X amount of writes per second, how is it going to impact my memory consumption if I'm using snapshotting. So as an example, again, here's a screenshot. I have 1.75 million operations per second on an existing database that's 52 gig. And mind you, what I've done here is taken the old approach where I've turned on AOF and or snapshotting on a database that has only a master, no slave. So you can actually see my memory consumption has increased, first of all, and more importantly, so there's a huge impact on my performance. My operations per second dropped drastically. My latency has gone up drastically. And you can also see that my total memory usage has gone up from what it was. There's an overage when I turn it on, right? The actual data set size is 52 gigs. Now I'm using 62 gigs. So there's an overage. Again, so this is another thing that you have to factor. It's a question of when you turn it on. If it's AOF, if it's snapshotting, then you have to factor in right at the beginning. Now, with Redis Labs, one of the things by default that we do, and as I had said, you need high availability slaves for high availability, but you need slaves for persistence also. If persistence is a strategy that you're using, with Redis Labs, what you can do is transfer or offload all this overhead to the slave. So the master can continue to perform and provide the performance it actually needs to. So the data gets replicated to the slave, and the slave then works with the disk to ensure that it's actually writing to disk. Still, that memory requirements do not go away. So moving on, the next piece is the data structures itself, right? We will cover this in detail, but one of the huge differentiators about Redis is a support for different kinds of data structures, which basically makes it more than a cache server. It's a data store or a data structure server. It provides a very powerful and efficient way of managing atomic operations, and it also has specific structures designed to handle memory very efficiently. And what I mean by that is you could have lists, you could have sets, you could have hashes that are using special encoding, and it could take as much as 10 times less memory than you would in a case of strings, right? And we'll cover that a little bit later, and I'll actually show you a few examples. And the other thing is the evictions. So if you're seeing a high rate of evictions, it means that you're pegging your memory, right? If you have defined 50 gigs and you're actually seeing, and you have defined the eviction method in your system, we have the ability to show you how the evictions are happening and how many evictions are happening per second. And if you're seeing a very high rate, you know that you're pegging the memory and you need to increase the memory. The other thing that you have to keep in mind is setting an expiration for the keys. So a lot of times, again, these are things that you have to consider when you're actually designing your application, right? And maybe not all of them will apply at the same time. Maybe not some of them won't apply in your case, but something that for you to consider. Setting an expiration is a much better methodology in trying to delete these keys from the system as opposed to having to run a del command. What happens is when you're running a del command on the key, you're involving the complexity that is involved for that particular operation. Plus, you'll also have to factor in the network latency to actually execute that command and get a response back. So if you do set the expiration, there's a background process that's actually running. That will actually start to delete these keys at periodic intervals. And it also helps manage stale data. And I believe I have a few questions here. I'm going to finish this, and I'll answer those questions. So basically, let Redis do the job for you. And one other thing to keep in mind is if you have too many keys expiring, that may also create a latency. So the process is every 100 microseconds, there's a process that's running, looking for the expired keys and deleting them, right? And if it deletes more than if it has more than 25% in the keys, it's going to go back and run the process again. So that could potentially use up the CPU resources. So that's something that you have to keep in mind if you have a lot of keys that are expiring. So going back to the questions, I have a few questions here. Can we use the multi-proxy option to overcome physical bandwidth or packet limits? The answer is yes, and that's one of the ideas. But it may not necessarily solve all the potential problems you may encounter because of your bandwidth problems, right? So that's something that we would love to discuss with you, looking at what your bandwidth is, and that would help us design how many nodes you would need and how many shards you would need and how you would have to distribute that across multiple nodes. Do I need to have one slave or two slaves for the quorum? So basically, quorum is independent of the slave. So you're going to have a slave for the master. The quorum is stored separately by the Redis Labs enterprise cluster. So we actually do only one slave. The advantage there is you're saving on memory, which is something very important, especially when you're talking about lots and lots of RAM. And then the way it is deployed across multiple nodes, or it's rack aware. So should a node go down, or it's automatically able to fail over to another node on a different rack. The last question here: how often can I AOF? Can I configure only the slave for AOF? So right now the F-Sync is every second. That's how often you can do it. And by default, if you do turn on replication with the Redis Labs Enterprise solution, the only way you will be doing AOF is via the slave. If you didn't have a slave or high availability, or if you haven't defined a slave, then it's going to be via the master, and you would see the difference in the performance. So moving on. How do you calculate the total number of shards? So before I get into that, I want to give you a quick example here. So as you can actually see, and I've used this screenshot quite a few times in the past screens here, I have 1.75 million operations per second with about 11.13 latency, right? And you can actually see I have about 1.25 million writes per second happening with about 500K reads per happening. So this is a very, very write-intensive database that I've created. I have about 52 gigs of memory, about 4.24 million keys. Now this is basically on a single shard. So once I increase, actually two shards. Once I have redefined this or increased the number of shards, you will actually see the impact. My operations per second has gone up, not significantly, but has gone up to 1.86 million. And my latency has fallen by almost 4 milliseconds. And you can actually see the difference between having a single shard and having multiple shards. So coming to the point, the difference is this, right? We normally recommend not have more than 50 gigs per shard. However, one of the things that you need to factor in are things like reads per second. How many reads per second do you expect? How many writes per second do you expect? What's your data size? Is it in bytes? Is it in kilobytes? Is it 4 KB? Is it 10 KB? Is it 32 KB? And what is the latency that you're willing to live with? So as you start to expect a higher number of operations per second, the data set size is inversely proportional to that. So the higher the operations per second, the smaller the data set size needs to be. So some of the metrics to watch, and I'll take some questions right after this. The memory consumption on the node should be, on any given node, should be less than 70%. The memory consumption for the cluster itself across all the three nodes, especially if you have multi-proxy solution or if you have a multi-tenant environment with several databases running across multiple nodes, still you need to make sure it's less than 70%. There are two ways you can actually change that. Should you see a consistent consumption of over 70% for a node, let's talk about that first. Then you have the ability to do something called rebalancing, right? And you can do that in real time. So with Redis Labs, you can actually move these shards to a different node where the resource is not being used as much. So that way you can alleviate the problem immediately. However, if you have an issue with the entire cluster performing at greater than 70%, you need to have two choices, either a vertical scaling or a horizontal scaling. Vertical scaling meaning you're adding more memory to the box. So that would definitely involve having to take the node down, right? So you have the ability to fail over these shards from that node to a different node and keep your application active, no problem. Or you can migrate these shards over to a different node and keep your application active while you perform this maintenance, add more memory, bring it back into the cluster. Should that node have a master previously, it'll rejoin back as a slave and perform a full sync with the existing master. And if it didn't have anything, it'll just rejoin back. And you have the ability to rebalance all of these shards across all the nodes again. Horizontal scaling would be adding more nodes, and I've run into this situation many times. A lot of customers have only finite amount of resources per node, especially when you're talking about ESX server, and that's the standard and that's the policy. So there's no way they can actually do vertical scaling. In that situation, you have no choice but to do horizontal scaling. So you can add more nodes to the cluster, and you can actually automate that using the REST API. You can easily join it to the cluster. You can spin it up. In fact, you can automate to a point where you can set up these alerts. You get notified. You can kick off a process that's going to spin up a new VM and install the cluster piece and automatically join it to the cluster. And then you rebalance the nodes. As soon as a node joins to the cluster, the memory that the new node has will be aggregated as part of the cluster. So you need to do two things. One is increase the size of the database and then rebalance the shards. Questions? So I have a question here. How are we able to inspect the per node metrics in our RLEC clusters? So the nodes tab has has a listing of all the different nodes that are part of the cluster. When you click on that node, you're able to see all the different metrics around that node. I believe I may have a screenshot here, but that should actually answer your question. Moving on, let's talk about cores to shard relationship. So that's the memory aspect. Now we're moving to the second aspect of performance. That's the cores. And a lot of times, yes, I get asked this question: how many cores do you need in the box? How many cores do you need in the box so that we can install that? I wish I had a standard solution or a standard answer for everyone. It actually varies. It varies based on your requirement. It varies based on what's your data set size. It varies based on how many shards you want. And we talked about calculating the shards, right? It depends on operations per second. What's the writes per second you have? What are the reads per second you have? What's the latency you're willing to live with? So all of these different factors influence how many cores you need in the box, and also the connections. So, and again, one of the key things is, I'm sure most of you on the call know, Redis is a single-threaded database. So that is one of the key reasons why it has the performance it has. So if you throw a box at Redis that is only, let's say, 50 gigs, and you have barely 10 operations per second, and the box has 16 cores, it's still going to use only a single core. So it is single-threaded, it will continue to use the same core. So the proxy is what we actually define, which will help you start defining more shards and using more cores. So every shard that you create within Redis Labs will first try to use an additional core that's available on that box or available within that cluster. If it's not available, then it's going to start using the existing core. The challenge there is if you have 4 or 5 shards, and if one of the operations you perform, and all of these are using the same core, one of the operations you perform is a huge keys command, for example, it's going to slow down everything that's following it, right? So that's one of the key things that you need to keep in mind. Some of the metrics to watch when you're looking at the core utilization. The optimal utilization should be anywhere between 30 and 60%. And if you're consistently around that 30 to 60%, I think you're fine. A single node utilization should be less than 75%. The cluster utilization, the aggregate, so the metrics for which you can actually see in the cluster tab, should also be less than 75%. And this is one of the screenshots for the cluster, which is an aggregate for the entire cluster metrics. But as you can see on the right side, you have the operations per second, which is about 1.53 million. This is the RAM, and I actually see a consistent CPU usage about 14.3%, which is absolutely great, right? And then you also have the connections here, 635 connections. So one of the things you need to watch out for is the connections. And the reason being, the higher the number of connections, and if you're not closing or returning these connections to the resource pool and they have persistent connections, you need to plan ahead, because the proxy, the way the proxy has been designed, it's multi-threaded and easily accepts several thousands of connections. And it's designed to scale based on the needs and will use additional cores should that need arise, right? So the more cores I can give, it's better, but depending on the number of connections, depending on how many connections are coming on, and what kind of operations you're performing. And again, you have the rebalancing option. So with the Redis Labs cluster, you don't need to have the same kind of nodes across the board, right? All 3 nodes need not be the same. They can be different. Some may have more memory, and some may have less memory. Some may have more cores, some may have less cores. So if that is the case, you have the ability to actually rebalance these nodes. The last piece, again, I just touched upon this. You can actually see the proxy aggregate CPU consumption for the node, right? And this is, again, the node metrics that I have a screenshot of. And you can actually see wherever I have the active endpoint, my usage is 30.5%. So if you have an active passive deployment of the endpoint itself, the cluster, right? So there will always be a single active endpoint where all the connections are coming in. So depending on the number of connections, depending on the work you're performing, and depending on how long it is available, in this case, I have 2.5K connections that are coming in. So the proxy will try to use or scale in or scale out depending on what's actually happening. So if you want to distribute the load, you always have the ability to use the multi-proxy option. Questions before I move forward? Okay. So the next performance monitoring aspect that you need to keep in mind is operations per second, right? Operations per second in Redis translates to the total number of commands that you execute out of the 180 plus commands that are there within a given second on Redis. And this is basically sending the request, the command, and getting a response back. While you're doing that, there are several factors that could influence the operations per second. One is the latency itself, the latency being the read-write latency, right? The data structures, and I briefly touched upon this a few slides ago. The data structures, as you know, the question is you have to ask yourself is, are you using the right data structures? So I've seen a lot of times that, you know, if you're migrating from other cache solutions, the easiest way to adopt Redis is use the strings, and that's great. But in some cases, depending on what you're trying to do, maybe your memory footprint will be significantly higher, number one, and maybe the payload may be significantly higher. So something that you need to consider while you're once you migrate or later to see if there is anything that I could do with the data structures. Is there an optimization that I can do around the data structures? And you can do this on the fly, and that's why Redis is so great. I mean, it's been designed that way, right? You have several different data structures that you can use. You have the lists, you have the sets, you have the sorted sets, you have the strings, and some of them have special encoding where you can perform this. The second thing, which is what leads me into, is a special encoding data structure. So for example, in this case, I created a key, 9116, and I put all these user details, right? And name is user 1, IP is 1111, hits are 1. And the same thing what I've done is I used an HM set, basically a hash, if you will, to store all these details. So if you actually see, this is from the Redis client, you actually see the usage for the string, average size is 40, and usage for the hash is only 4. So again, there's a huge difference, and this is just for 2 keys, the difference between a string and a hash, right? So imagine the amount of memory you could potentially save if you start thinking about all the different use cases you have and how you can best take advantage of the right data structure that Redis provides. And you can and this is where you can make these changes. You need to strike a balance again. You have these different special encodings for the hashes, the lists, and the sorted sets and the sets, and you can actually toggle with these values, but you need to find the right balance between having these values here and how it's impacting the performance. The trade-off at one point, there won't be much of a trade-off. And how do you change these parameters? Is basically go in here, you can use the config get and config set command, and Redis Labs absolutely supports this. You can make these changes and in a real-time environment. So the other aspect that influences the operations per second is the commands itself. A lot of times people wonder, okay, I have a lot of commands going. Yes, the volume of commands going to your Redis database does matter. And how you go about doing this is also going to matter. Say for example, the single commands, right? It's the set, the get. If you're doing a single command, you're going there and inserting the data. Like in the previous example, right? Like in the previous example I have here, which is a HM set where I'm actually setting multiple keys at the same time. It's a single operation for Redis. But imagine if you actually had to set each one of them for the hash. I do a 8 set for 9115 user ID. Then I do a 8 set for 9115 name. 8 sets. So there are 4 commands that you're actually sending, which incurs not just an execution time on Redis's part, but you're also incurring the network latency because you're trying to execute these commands. So you can actually use a single command. That is what I was talking about here, a multi-command, and then execute all of this at the same time without incurring too much latency. Those were some of the commands that you can think about. The second way of actually improving your performance or reducing the volume of commands that are going is the pipelining them. And it depends on your use case. Maybe you don't have a way to actually implement this. So this is, but definitely this is something you should consider on how you can improve performance, right? The idea is to reduce the network latency. So typically what happens, and let's take an example, right? If I want to be able to write 3 keys, I want to be able to write user ID 1, user ID 2, and user ID 3. If I were to do a set command, set user ID 1, and set user ID 2, and set user ID 3 as 3 separate commands. So I initiate that from my client, it goes to the server and gets a response back, okay, then I initiate a second set command and a third set command. Now, a typical 1 gig network, let's say has about 200 millisecond latency. And let's say you have a Redis that is offering about 50,000 operations per second. Now you're basically, what is happening is you can perform only about 10 operations per second if you actually did that, right? So if you were to use a pipeline, all that is going to happen is I do set user 1, set user 2, set user 3, and then send it to Redis database. I get a single response back. I'm actually saving about 200 milliseconds of network latency, which is about 200% gain on a network. So that's something that you need to consider. As you queue commands, this is another key piece that you need to consider. As you queue commands, there will be an additional memory usage, and you need to make sure that you have the right pipeline setting. The next one is the slow commands. So Syslog in Redis is one of the best tools, right, for debugging and tracing your Redis database. So what are slow commands? These are things that actually take, that have a high level of time complexity, right? The larger the data set size, the longer it takes to process them. Some of the examples are zinterstore, zunion store, senter, sunion store, all of these different commands. You can actually look this up. So as the complexity of a particular operation grows, and if your data set size is growing and the more data you're storing in these sorted sets or sets, the longer it's going to take. So Redis provides a beautiful tool. I'm just talking about Syslog, right? And it basically helps you identify the complexity, how long it is actually taking to execute a specific command, right? It could be one of these high complexity commands. So one of the enhancements Redis Labs has done is the ability to provide the complexity info. So if you actually look at the logs for Redis, the logs we create, or in the UI itself, you will actually see something called the complexity info. In this example, I'm doing a zunion store for more than 37 sets and then storing it in a single set. And the total number of values in an element in a single sorted set, the highest is 2,640. The resulting value also is 2,640. So this is what is the total complexity info that we're providing. And this is the execution time. You can actually see 10.992 milliseconds. So one of the things you need to keep in mind as you start to use these highly complex commands is to ensure that you don't take up too much time of the Redis database, because it's going to affect any commands that are following this command, right? So you'll start to experience a higher latency. The other example here is a zinterstore, and it's the same complexity information here. Any questions before I move on? Okay, so the network latency is another thing that you need to consider. So first of all, okay, the idea is, okay, do I use a 1 gig or a 10 gig? Our recommendation is always 10 gig. Most of the time, you're always limited by your network capacity more than the Redis latency itself, right? But I have run into environments where you have no choice but to have, but have 1 gig network. But the ideal recommendation is have a low latency and a high throughput network. And you should also consider the payload based on the data structures and connections you're using, right? How many connections are actually there? How are you connecting to these Redis databases, right? And are you choking the network just by the number of connections you have? And also, what's the payload that you're incurring by transferring data back and forth? Let's assume that you're using a JSON. The JSON is, let's say, 32 KB or even 1 MB. And if you have to make small adjustments to the JSON itself, now you're transferring back and forth a 1 MB file, and maybe you have 30 different clients doing the same thing, right? Maybe it's time to think about data structures if you just have to change a few attributes. Again, something to think about. The other aspect that you need to think about when you're talking about network latency is the other things that you're doing with Redis Labs, right? It's not just the applications accessing the data. It's also the replication and the replica of. The replication involved, we talked about the memory overhead, but also you'll have to think about the network overhead, right? If you're replicating from master to slave, and if you have a high writes per second environment, then you're going to incur a little bit more network throughput. And similarly with the replica off. One of the things that you need to plan for with the replica off is should you have a failure, for whatever reason the connection breaks and you need to resync back. That's what Redis does. It's going to sync back. It's going to perform a full sync with the master. You need to consider that you're going to be transferring this data when it starts to full sync. So here's a small example here. I have a database basically performing a lot of operations, 1.55 million operations per second with 1.11 writes per second. As soon as I turn on the traffic, as you can see, the traffic actually grows by almost 100%. So again, you need to keep that in mind and make sure that you design while you're doing this. Yeah, pipeline commands. That's something with Node.js I need to check and get back in terms of the Node.js client itself. So I'm going to check and get back whoever asked that question. So we'll make sure that I get back to you. Any other questions? Does a slow log also have client application making the connection per operation, or is it another debug setting? No, the slow log has no client application making the connection operation. It's actually created in the memory. The slow log is stored in the memory. That's why it's able to provide the performance that you need. There's no other debug setting, but there are certain debug settings that you can set. But my disclaimer is that you need to get in touch with the Redis Labs support to help you through that. We normally don't recommend changing those parameters because it's already optimized. There's a question back from the zero latency proxy. How does this help with distributed applications? Regardless, I believe the proxy has nothing to do with how distributed you are. It's going to help. The multi-proxy is going to help you connect to these database that's actually sharded across multiple nodes. So if you have a cluster that's actually spanning a couple of different data centers, again, the deployment is a critical piece. You'll have to consider the network itself. It's deployed across multiple data centers, and it's let's say, for example, AWS itself. You have 3 different nodes deployed across 3 different zones. If you have the multi-proxy option, you can actually connect to any one of these, and if the data doesn't exist there, it's going to get redirected to a different zone, and you get the node data back. Now, there's another option when you're talking about distributed. It could be geographically remote. In that case, a cluster, we normally don't recommend deploying a cluster across geographically remote locations, especially with the network kind of network you may potentially have, right? And what kind of bottlenecks you have. The replica off option is the best way of going about doing that, and you can configure your applications for all read or based on GeoIP. You can go ahead and access the replica off, and then for all write applications you can get here. So there are different ways of deploying that. Do you have any reference model for use in the ASP.NET implementations? I'm not sure I understand what that means, but hopefully somebody that can clarify that, and I can move forward here. So the operations per second, the other thing that you need to keep in mind is, of course, we already talked about this, the coarse to shard correlation, right? It's usually a one-to-one mapping. So when you actually design the number of shards, or as your data set size grows, you're increasing the number of shards. You need to make sure that there are enough cores to support that. And then also cores to connection correlation. You need to make sure that there's enough cores available for the proxy to scale and scale out if you have a huge flood of activity that's coming in over and above what you've already designed. So the higher connections may require additional cores. Multi-proxy functionality will help you distribute that across multiple nodes. There's another piece that is extremely important, that's the proxy threads. And again, typically this is auto-scaling, and we normally don't recommend that you go in and change it, but we have had situations that customers had to do it, right? But and that's the command that you do. You can use the RLadmin utility and play toggle with the number of threads. However, the disclaimer is, should you need to do that, or should you feel that you have a need to do that, I believe you should actually get back to Redis Labs support, confirm that that's a requirement and that indeed is the problem, so that they can analyze the logs and that they can confirm that that indeed is a problem, and then you need to increase the number of threads. So before I move into the Syslog integration, I have a few questions here. Snapshotting in Redis, does this affect Redis performance? We have seen connection issues when we enable snapshotting in Redis. It absolutely does, as I covered a little while ago. There's an extreme case where you may need double the memory, and it's actually trying to write to disk, and I've actually showed you the screenshot how it affects the performance of the master. But with Redis Labs, what you can do, and if you're not doing that already with Redis Labs, what you can do is make sure that you define high availability so that the snapshotting will always happen from the slave, and it will not affect your master shard, or the performance of the master shard. Okay, so somebody did confirm ASP.NET is deployed on IIS. On Windows, Redis is Linux-based. How can both work together? The communication between the two is using the Redis protocol. It has no relevance with the operating system. So we have a lot of customers who have already deployed it. You can absolutely deploy that. So as soon as you configure, it's basically in ASP.NET, you configure the connection string and the port number that you need to connect on. That uses the Redis protocol to go talk to the database directly. Think of it like this, if I could draw a parallel. If you have an Oracle running on Linux, but you have an IIS connecting to a backend Oracle, right? Regardless of what operating system they're running on, you're using a database protocol, that will facilitate it to happen. So you should be able to do that without a problem. So moving on, Syslog integration, and I'm going to focus on Splunk here. I have a few screenshots. It's a two-step process, right? You have to make a change with the RLEC server configuration itself, and the second change would be on the Splunk server. So what we have done, because of the REST API we provide, that's quite robust. It gives you a lot of flexibility on how you want to handle this data. You can very easily access it via the metrics, right? You can use it in any which way you want. If you want to specifically do it with Splunk, what you can do is go ahead and turn on the rsyslog config, the config file, rsyslog on the Redis Labs servers, right? And the way to do it is go ahead and change that and add your host name and IP address along with the port. And that's exactly what I've done. I've defined that here. And the second step you need to do is you need to configure your Splunk server to receive the data. And the way you would do it is you'll define the data inputs here, and you will use the REST API. And the REST API, we have the documentation. We can provide what specifically and how specifically you configure that along with the commands. And once you do that, you should be able to see all the data from by using the REST API in your Splunk. Now you have the ability to filter out a lot of things. You can keep what you want once it gets to Splunk, and you can discard the things that you don't need. So I have a few other questions here. What are the advantages, disadvantages of storing data in hashes versus just as regular keys? What happens when you shard? Does the entire hash go to one shard? So basically, whether it's a hash or a string, it's a key, right? So if I'm storing something as HM set user1, the hashing is happening on the key and not the value, not the attributes. So whether it's HM set user1 or set user1, the hashing will happen on the user1, right? So if I did, when the hashing happens, it generates the hash slot for user 1 and figures out which shard it needs to go on. So when you go and do a mget or hget for user 1, it knows, the proxy knows which shard this key exists on along with the attributes, and it's going to go ahead and retrieve that. So the hashing is always on the key and not the values. Is there a way to integrate Redis monitoring with Oracle EM? That's a great question. That's something I need to check. As long as Oracle EM has something, has the ability to make REST API calls, which I believe it may, you should be able to do that. Any other questions? Okay, so just a quick recap here. We discussed the different performance considerations that you need to have for Redis, right? And if I have to categorize them as broad categories, I would categorize it this way: physical hardware, data structures, and use cases, and sharding, right? Physical hardware includes the core. So you need to consider the number of cores you have and how does it translate to the number of shards you have and the connection so that the proxy has enough cores to work with. You need to, with the RAM, you need to consider what's your total database size, not just the masters. It's masters plus slave. And you have about 5% for the replication itself, and about 30% if you're doing the replica off. So those are some of the things. And I would normally, my recommendation is have an overage of 25 to 30% above, over and beyond what your data set size is. That is master plus slave. The disk options, we normally recommend 5 times the size of the disk. And you can use a network-based storage, so it's very easy to recover if you actually want to replace a node or remove a node, and if you're using the persistence file. But that's some of the optimizations we have done around persistence. The second thing is the data structures and the use cases. Please, please, please consider all the different data structures you have at your disposal and how you can use them, right? Typically, when we're moving from a different environment, it's usually very easy to just use the strings, but Redis is a lot more than just strings. Each of these data structures has been designed for specific use cases, and you can use several different data structures together to satisfy a use case and get a very good performance. And lastly, sharding, right? Please be aware that there are several ways you actually calculate the shards, right? Several parameters that you need to calculate the shards. The operations per second, the acceptable latency, the data set size that you have, and data set size and operations per second are inversely proportional. The number of connections that are coming in, and maybe potentially what's the size of your hardware, right? If you have a very small, very limited capacity with your hardware, maybe you'll end up having more nodes, which means that I may end up having to create more shards. So, so with that, thank you, and thanks. If there are any other questions, I'm more than willing to answer them. If not, thank you very much for listening.
Hey, thanks, Madhu. Very, very compelling topic. And thanks to all of you for joining us this afternoon and this morning. An email will be sent out with a link to the recording for you to share with all of your workmates. I hope you all have a great day, a great next week, and that concludes our broadcast. Thank you very much.